The following presentation is a demo of planning and executing a synthetic chemistry experiment in Scientific Notebook on the 3D Experience platform. My name is Jen Teskey, and I'm a solution consultant for the BIOVIA Enterprise team. This presentation is being made using platform version 2023 FD04. We'll start with a brief overview of Scientific Notebook, then walk through the synthetic chemistry demo, ending with a summary and value of Scientific Notebook. Scientific Notebook is our next-generation lab notebook hosted on the 3D Experience platform. It's a brand new ELN being developed for all labs across all product development life cycles for both regulated and non-regulated environments. Scientific Notebook takes advantage of our proprietary experimental data model, which is based off of graphical RDF technology. This allows us to parameterize data recorded in experiments. One of the basic tenets for Scientific Notebook is that we want scientists to be able to enter data any way they want, whether that's free text, spreadsheets, voice control, or through other files. Behind the scenes, our graphical data model, combined with natural language processing, is able to pick out parameters being entered and index them into our data model with context so they can be extracted later and used for analytics. Another thing we've included is the ability to consolidate all of your ELN data. We understand that companies are using many different scientific notebooks, and migrating to a new platform requires the ability to import legacy data. So consolidation was a key feature that we had built in. Since this is a new product, we're still developing functionality. And right now, Scientific Notebook has 3 templates, one for a generic experiment, one for synthetic chemistry, and one for formulation design. We're going to be spending the bulk of this presentation looking at the synthetic chemistry functionality, but it's important to note that Scientific Notebook is also integrated with our laboratory suite of products that are hosted on the platform as well. In the demo, I'm first going to introduce you to our fictitious Bio944 synthesis, and then walk you through 3 scenes. In the first, we'll focus on searching for experiments. Then we'll review our chosen experiment, clone and modify it, incorporating our planned reaction values. And finally, we'll act as if we've run a series of 3 reactions where we've recorded the results in parallel and take a look at those results. So to start, we're going to take a look at this Bio944 synthesis. Now, Bio944 is a 5-step synthesis where the team is trying to optimize each step. And here on the screen, you can see a summary of the complete synthesis along with each chemical transformation. Within our story, the team has just finished optimizing step 1 with the addition of the oxalyl chloride to the 5-bromo-indol and is getting ready to move to step 2. In step 2, we're pulling off the chlorine to form the amide. We're going to focus on creating this reaction in a new experiment within Scientific Notebook. And we're going to do that by searching for this experiment and cloning it. So the first scene of our demo involves searching for data within our Scientific Notebook. I'll start by walking you through the home page so you can review all of the experiments the notebook contains. Then we'll open the search engine that runs behind the scenes for all of our notebook data. I'll walk you through the different ways we can search for the experiments. Once we find our experiment, we'll review the data so you can see how the reaction scheme, stoichiometry table, and write-up section are set up. Then we'll clone this experiment, and I'll close the scene out by changing the experiment name and modifying the write-up. So moving over to our live environment, you can see that we're looking at the home page for Scientific Notebook. And I'm going to start by opening up our scientific search functionality. This opens a pop-up window that sits on top of Scientific Notebook and allows you to conduct searches. You can see that we have almost 900 experiments in this notebook. So to find what we need requires us to narrow down the results. And you'll note that searching has a similar feel to what you would experience in SciFinder or Reaxys. There's a generic button at the top that allows you to search for free text. So for example, if I type in the word synthesis and hit enter, you can see that our results immediately went down to 69 experiments. If I want to preview any of these experiments, I can click on them, and a preview will open on the right. So it gives the title of the experiment number, you can see the chemistry, and when I scroll down, you can see some metadata around the experiment. To narrow down the results further, I can make use of the filters that are over here on the left. So for this example, if I open the department filter, I can scroll down and I can select medicinal chemistry. And you can see an orange dot here indicating that the filter has been activated. So I'll click apply. And now our results are reduced to 16 experiments, and we have the beginnings of a breadcrumb navigation trail across the top. So if I select a second filter, project, and I choose, in this case, Bio943, and hit apply, our results are narrowed down to 8 experiments. And you can see which filters are active by the blue dot that's next to the category. Now, since we want to focus specifically on chemistry, I'm going to close out of all of these filters so that we can hone in on the chemistry search that you see across the top. So if I open chemistry search, this is going to open a drawing editor that's built into Scientific Notebook. The drawing editor that we have built in is Pipette Sketcher, and it was chosen because it works very well on mobile devices. It allows us to run a reaction search by drawing an individual molecule or reaction. So for this particular example, I'm going to keep it very simple and make use of the templates and select indole. But you would be able to open this up and build upon it should you desire. From here, though, I'm going to go over to the right where you see Select Options. Now, what this is searching on is all of the experiments within your scientific notebook. So specifically, it is going to be searching on reactions. But since we have chosen a structure in here, we have the ability to look at the search type, and if we click on this drop-down arrow, I can keep this as a substructure. I can search it as an exact structure or as an exact structure with salts or stereoisomers or tautomers, or I could run a similarity search. For this example, I'm going to leave it as substructure, and then below that you see role in the reaction. So it is running a reaction search, and I can choose that this can be any role in the reaction, or it can be a reactant, a reagent, a product, a solvent, or a catalyst. So for here, I'm going to leave it as any. I'm going to go ahead and click Confirm. This loads that substructure into the chemistry search filter. And if I go down and hit Apply, now I have that chemistry search filter across the top, and my results have been reduced down to 27 reactions. So in keeping with our story, at this point, I'm going to now go and search by project, and I'm going to select Bio944. So now we have 5 experimental results that you can see, and all of them relate to this Process A, Step 1 of the Bio944 synthesis that I pointed out in the beginning of the demo. So if I select any one of these to preview them, I can see the actual chemistry, and when I scroll down, I can see the yield. And so this reaction was run several different times, and you can see that this example has a very low yield. So it's not the one that we want if we're going to begin cloning our experiment. So if I close this out, the final filter that I'm going to apply is all the way on the bottom, and it's a filter for yield. I will open this up, and then you can see the range of the yields that are given in the experiments that are on display. And if I take the slide bar and I slide it all the way over, I can specify that I only want to look for reactions that have a high yield. I'll hit Apply, and now we're down to one search result, this Bio944 Process A Step 1, and I've labeled it Optimized just for the demo purposes. Once we have the reaction that we want, in order to open it in our notebook, it's as simple as dragging it and dropping it. And now the experiment will open for us to look at. What you're looking at is the synthetic chemistry template for Scientific Notebook, and it has 3 blocks that you can work within. On the left, there's a write-up block, and then you have your reaction scheme and your stoichiometry table. And within this template, there's a fluidity to working with all of the blocks. You can make any one of them larger so that you can see things more directly. And within the write-up block, you have the flexibility to create your procedure as you go. And you can also add attachments to this write-up block. So if you look for this procedure, we have text written in it, and below we have some data that's associated with it. The data is represented as a thumbnail, but if I click on Display Preview, I can see this thumbnail in a larger view. And beneath this section, I have one final section that also has data associated with it. Now, to prepare for step 2 in our synthesis, I'm going to take this experiment and I'm going to clone it. Once the cloned version opens, I'll go over here and I'll change the title. I'll close the Properties panel, and then I'll go over to the Write-Up section and I'll delete my procedure. I'll remove this data, and I'll delete the last section. From here, I'm ready to begin experimental modification. What you just saw in the live environment was us reviewing the Scientific Notebook homepage, and then we opened up the search functionality that runs behind Scientific Notebook, and we searched for different experiments. Once we found the one that we wanted in order to build off of to begin step 2, we reviewed that experiment and opened it. We went through the different blocks, and then I cloned it, I deleted the procedure section, and I got us ready for making our modifications. So in the next scene, we are actually going to go through modifying the chemistry. The first thing that we're going to do is modify the reaction scheme and the stoichiometry table, and you will see that the two are linked. So what we do to one will apply to the other. Then we're going to go into the stoichiometry table and adjust the table view so that we can delete the actual amounts from the old experiment, fill in our planned amounts, and then we'll import a procedure and import an equipment image. We're back in Scientific Notebook, and the first thing that we're going to do is modify the reaction. And I'm going to start within the stoichiometry table. So I'm going to expand this to make it easier for us to see. And the first thing that I'm going to do is take these two reactants and delete them. Then I'm going to take the product of the first reaction and I'm going to change its label in the role column to make it a reactant. And I will also make it the limiting reagent. Now, if I minimize the stoichiometry table, you can see that the changes that I made within the stoichiometry table reflect the reaction scheme. For the next part of the modification, I'm going to work within the reaction scheme. And what I'm going to do is actually edit this reaction. So I'll click on this pencil. The reaction will open in Pipette Sketcher like we saw when we were doing searches. And for here, I'm going to keep it very simple. And I'm going to take the reactant and I'm going to copy it to my clipboard. And I'm going to make it the product. And then I'm going to modify the product itself. I'll hit Submit. And you can see that the reaction scheme has been modified. When I minimize this and maximize the stoichiometry table again, you can see that we've got a label for the product on the bottom. The next thing that I'm going to do here is actually add an additional reactant. So I'm going to go up to this Add a Row, and then within here, I'm going to type in the name of the reactant. I'll hit Enter. It will search the system, and if it finds a match for the structure like it has, it will bring it directly into my stoichiometry table. Now, anytime I bring in a new chemical into my stoichiometry table, by default, its role is reagent. So the first thing that I need to do is make this a reactant. And then I'm going to go ahead and move it up in my table. The final thing that I'm going to do is add a few additional solvents so that we can run some screens in parallel. So for this, I'm going to go to the arrow next to the plus sign, and I'm going to go to Search and Import. This is going to launch the search engine that we were working with before, but instead of searching against reactions in our notebook, it's now going to search against compounds within our materials management library. So the look and feel is the same, indicating that you can see how many compounds we have in our materials management library. We've got the ability to do the text search, and we have the filters over on the left. For this example, I'm just going to use a text search to narrow down my results. But we could have used the filters as well. The format is the same, but the filters are different to reflect what it's searching against. So for here, I searched THF, I'm going to find tetrahydrofuran, and I'm going to drop it into my stoichiometry table. And then I'm going to run a second search for DMF. Once it comes up, I will also drag that into my stoichiometry table. And I'll go ahead and I will close this search box. Looking at the stoichiometry table, you can see these 2 additional compounds have been added. I need to change their role to solvent. And then I'll move the product to the bottom. To round out our experiment plan, I need to adjust my planned amounts. So the first thing that I'm going to do is change the view. The stoichiometry table has a default view, but you have the ability to change that view based on your own preferences. So I've gone ahead and I've created a view here for myself, and in that view, I've got all of the amounts column, and these amounts are the actual amounts from my previous experiment. I will delete them, and then I will fill in the planned amounts for the new experiment. For the limiting reagent, I'm going to make it 5 grams. For the N-methylmethanamine, I'm going to make it 1.1 equivalents. For the TEA, I will keep it at 1.25 equivalents, and for all of the solvents, I'll change it to 8 ml per gram. You can see that some calculations have been auto-populated, and now I'm ready to go. So I'm going to minimize the stoichiometry table, and then the last thing that I'm going to do is input some text into my procedure section. And I'll round out this scene by dropping in an image of the desktop reactor that I plan to use. In this scene, you saw how we were able to seamlessly move between the different blocks to make adjustments, and how we were able to search for materials for our stoichiometry table in a number of different ways. You also saw how we were able to import a procedure and attach an image file. In the final scene, we're going to tease apart the screening experiment I set up in scene 2 and look at 3 separate experiments running concurrently. I'll fill in the actual amounts for the DCM experiment, create the write-up, and import TLC analytical data. Then we'll take a brief look at the other 2 experiments that already have data added. We're back in Notebook, and you can see that this is the screening experiment we just created. But if I draw your attention to the top of my screen, you can see that this is the screening experiment, and I have gone ahead and teased the screening experiment apart into 3 separate experiments with each individual solvent. As of today, we don't have a way to label the separate tabs with our experiment names, but you can have several experiments open at the same time running concurrently. So if we rotate over to the DCM experiment, you can see the reaction is identical with the absence of the 2 extra solvents. And if I expand my stoichiometry table and change my view, I can input the actual amounts that I used when this experiment was run. And then if I scroll over to the right, you can see that the yield was automatically calculated. So I'm going to go ahead and minimize my stoichiometry table, and then I'm going to input data into my write-up section, dragging and dropping the TLC data, and adding 1 additional section. If I toggle over to the THF experiment, you can see the data that was incorporated. And when I scroll down, you can see that the yield was 62%. That matches the information in the stoichiometry table. And that the DMF experiment had a yield of 47%. So you have the ability to set up several experiments in parallel and rotate among each one, incorporating the data as it becomes available. This rounds out our demo. The key point of this scene was showing the ability to record data in different experiments running at the same time, and this functionality will improve in future releases. Scientific Notebook is a powerful new electronic lab notebook for experiments. It offers complete end-to-end lab workflows across all scientific domains and organizations. The digitalized data gives freedom to do science and analytics rather than hunting for and organizing data. Scientists will be able to work in the medium they prefer, whether that's a spreadsheet, free text, or tables, and on the device they prefer, be it a laptop or a mobile device. And automatic system mapping will make the data easy to find and use. We have support for open APIs and open ontologies, an open laboratory ecosystem, and process-based models. Thanks so much for your attention. Feel free to reach out with questions.